Alright, so hi guys. So in this video, we are finally going to get into inverse trig function derivatives. Now, I have 5 examples that I'm going to go over in this video. Let me go ahead and write all the rules down very quickly for the trig function derivatives, okay? Okay, so these are the derivatives for the 6 inverse trig functions. I recommend that you copy them down if you don't know them by memory. But, yeah, I mean, obviously, for me, yes, sometimes I do forget the derivatives for these, which is why I have them written on paper. And I already did the problems that we're about to do. So, and like I said, honestly, I'm not perfect, so if there's a mistake that I make that I'm not aware of, because obviously I made sure beforehand to do this correctly, but if there's a mistake that you catch that I'm not aware of, please let me know. So basically, the first one that we're gonna do, and we're gonna go over five problems in this video. So the first one that I'm going to do is a very simple one, but we're going to use chain rule for this one. So the first one is sine inverse of 2x. Now we want to find the derivative of this function. So this one, the way that you're going to do it, you're going to use the rule that for sine inverse of x, which is basically, you're going to say the following, and like I said, I highly recommend that you did copy these down, because these are the ones that I'm talking about. So I really recommend that you copy them down so that you can understand exactly what I'm doing in the video, because these are the ones that I'm using for this video. So really, I mean, you would say that u is equal to 2x, and u prime is going to be equal to 2, right? And let's see. So it's going to be, so the derivative of sine inverse is going to be, it's going to be u prime over the square root of 1 minus u squared. Now, we know what u is 2x, and so we're going to say f prime of x is going to be the quantity 2x prime over the square root of 1 plus 2x quantity squared. So then we're going to say that this is equal to, so f prime of x is going to be equal to the quantity, so the derivative of 2x is just 2, and then over the square root, and we're going to say 1 plus, and then 2x quantity squared, that's just 4x squared. So this would be your answer for this one. This one's pretty easy. It's not really that hard. The second one is a little bit harder, so the second one says f of x is equal to cosine inverse of 3x plus 1. Now, the derivative of cosine inverse, like I said, cosine inverse of u d du of all of this is equal to negative 1 over, or actually it's going to be negative u prime over the square root of 1 minus u squared. Right? So, so in reality, we're going to have, so u is defined as 3x plus 1. U prime can be 3. And so then we're going to have that the derivative f prime of x is going to be equal to negative the quantity 3 because that's u prime is 3, over the square root of 1 minus the quantity 3x plus 1 quantity squared. Okay, so this ends up being f prime of x equals negative 3 over the square root of 1 minus the quantity 3x plus 1 quantity squared. Now you don't have to simplify this any further, you can just leave it how it is. So this is how you would leave it. And then number 3 says f of x is equal to, and this one again, it's a little bit harder, so secant inverse of the quantity x cubed over 3x plus 4. Now this one is going to require a little bit more work. For this one, we're going to have to find, so again, we have u, right? U is equal to x cubed over 3x plus 4. Now we're going to have to find u prime. So u prime is going to actually be x cubed prime times 3x plus 4 minus 3x plus 4 prime times x cubed. I'm using the quotient rule here. All over 3x plus 4 quantity squared. So then x cubed prime, that's just going to be, so u prime is going to be, so x cubed prime is 3x squared, and then times 3x plus 4, and then minus 3x plus 4 prime, that's just 3 times x cubed, all over 3x plus 4 quantity squared. Okay. And then I have u prime is equal to 3, so I'm going to do distributive property here. 9x cubed plus 12x squared minus 3x cubed all over 3x plus 4 quantity squared. So then this will be, so u prime is going to be 6x cubed plus 12x squared over the quantity 3x plus 4 quantity squared. Now, that is what u prime is. U prime is going to be 6x cubed plus 12x squared over 3x plus 4 quantity squared. And so we're going to have, so let's see. Let's see here. Give me 1 second. I'm trying to see how I'm going to write this. So basically the derivative of secant inverse of u is going to be u prime over u square root of 1 of not 1, u squared minus 1. So u prime, we know what u prime is. So basically we have, so if we kind of do this here, right, u prime is going to be 6x cubed plus 12x squared over 3x plus 4 quantity squared, right? And then over, and what is u? U is x cubed over 3x plus 4. And then times the square root, and the reason why I write a huge square root is because it's times the square root of u squared minus 1. So u squared minus 1 is going to actually be x cubed over 3x plus 4 squared minus 1. Now this is going to simplify to, So we're going to have f prime of x is equal to 6x cubed plus 12x squared over 3x plus 4 quantity squared divided by x cubed over 3x plus 4 times the square root of x cubed over 3x plus 4 quantity squared minus 1. Now you can rewrite this. You can rewrite this as the following, okay? So we have f prime of x is equal to 6x cubed plus 12x squared over 3x plus 4 quantity squared times, it's going to be, so, or actually, hold on, give me 1 second. It's going to be the following. It's going to be divided by, not times yet. We're not doing them times yet. So it's going to be divided by, you can rewrite this as the following. X cubed times the square root of x cubed over 3x plus 4 squared minus 1 over 3x plus 4. So then this simplifies to 6x cubed plus 12x squared over 3x plus 4 quantity squared times 3x plus 4 divided by so let's see, hold on. Divided by x cubed times the square root. I'm going to write a huge square root, like a big one, of, or actually I can write it this way, hold on, times the square root of x cubed over 3x plus 4 quantity squared minus 1. And as you can see, you can do a few things. So number one, you have x squared times 6x squared, and yeah, I'm just going to do it that way, times 6x squared plus 12, and then you have a times 3x plus 4 all over, and you're going to do 3x plus 4 times 3x plus 4 times x squared times x times the square root of x cubed over 3x plus 4 quantity squared minus 1. Okay. This simplifies to 6x cubed, or actually, hold on. It's, so, okay, so these two cancel out, and these two cancel out, so then you're left with 6x squared plus 12 over 3x plus 4 times x times the square root of x cubed over 3x plus 4 quantity squared minus 1. And then you're going to say that this is just 6x squared plus 12 over 3x squared plus 4x, and you're going to do it all in parentheses and then do this in parentheses times the square root of x cubed over 3x plus 4 quantity, like quantity squared minus 1. I mean, you can simplify it more, but it takes really long. So I would just leave it like this. This one's a weird one. I made it up. All of these, I made them up. So number 4, we're just going to move on to number 4. This is number 3. Okay, number 4. Number 4 says negative cosecant. So f of x is equal to negative cosecant inverse of 8x squared plus 2x minus 1. So this is going to be, so the negative, so basically d du of cosecant inverse of u is going to be negative 1 over the square root of 1 minus u squared, or negative u prime. So here, u equals 8x squared plus 2x minus 1. U prime is going to be 16x plus 2. So then we're going to have the following. F prime of x is equal to, and it's going to be the negative, the quantity, and it's going to be negative of let's see, hold on. Negative of 16x plus 2 over the square root of 1 minus the quantity 16x plus 2 quantity squared. So then we have so then we're going to have f prime of x is equal to, the negatives cancel out, so we have 16x plus 2 over the square root of 1 minus the quantity 16x plus 2 quantity squared. And that's your answer for this one. Okay. Now the last one, which is number 5, we have f of x, and this one is a chain rule. Okay, so this one's a lot more tougher. We're gonna have f of x equals tan inverse of the natural log of 3x squared. So obviously, first what I want to do is I want to define u as the natural log of 3x squared. Now u prime, we're going to do, so remember that, so for example, if I want to take the natural log, so the derivative of the natural log of 3x squared, this is going to be equal to, so it's going to be u is equal to 3x squared, du is going to be, or u prime rather, I'm just going to say u prime, it's going to be 6x, and then I have, this is just going to be, it's going to be, so I'm going to say that du of ln of u is equal to u prime over u, right? So, like, basically, this is going to be 3x squared prime over 6x, which in reality, or actually, hold on, my bad. 3x squared prime, which is really 6x, over 3x squared. So this is going to be equal to 6x over 3x times x which is really just 3 times 2x, or really, I can say 2 times 3x over 3x times x. This is just going to be 2 over x. So that's the derivative of the natural log of 3x squared. It's 2 over x. Right. Now, so basically, we have u and we have u prime. Now it's time to do, so basically we're going to have, so f prime of x is going to be, and the derivative of tan inverse, so du of tan inverse of u is just going to be 1 over u squared plus 1, or, and then times u prime, or it's going to be equal to u prime over u squared plus 1. So this is going to be equal to u prime, which is really it's really 2 over x over it's going to be, because that's what u prime is. U prime is 2 over x, and then over 1 plus, or I can say whatever u squared is, so ln squared of 3x squared. So basically I can write it this way. That's u squared and then plus 1. And then this is going to equal 2 over x divided by ln squared. I can write it like that, ln squared of 3x squared plus 1 over 1. This is really 2 over x times 1 over ln squared of 3x squared plus 1, which is really 2 over x times the quantity ln squared of 3x squared plus 1, or 2 over x ln squared of 3x squared plus x, like this, any of these two. Okay guys, so that is it for this video. If anybody has any questions about this stuff, let me know. This was for inverse trig derivatives, inverse trig function derivatives. So in reality, like, I thought it was going to be longer. It's not really that long, but I only went over 5 problems in this video because I don't want to make it too long. But if anybody has any questions, let me know. Please like, comment, and or subscribe. And in the next video, let's see. Hold on. Okay, guys, so I believe that's it for this video. I only went over 5 problems in this video, so I think I'm going to stop it there. What I'm going to do in the next video, so basically now we've done inverse trig derivatives, logarithmic derivatives, power function derivatives, and then derivatives using power rule. We've done quotient rule, we've done chain rule, we've done trigonometric derivatives as well. So now that we are done now that we are done with the basics of finding the derivative, of how to find a derivative, we're going to move on to how to find the equation of the tangent line at a point. which involves finding the derivative. Okay, so and then from there we're gonna move on to doing, like, just the applicational parts of derivatives, the application problems of derivatives. So with that being said, guys, thank you so much for watching. That is going to be in the next video for, well, I'm gonna do in the next video I'm gonna do equation of the tangent line in the next video. So stay tuned for that, and I hope this helps, and thank you so much for watching, and I will see you guys next time. Bye, guys.